Hello, friends. In this session, we will discuss the examples based on projections of solids. Example number 1. A cone diameter of base 60 mm, height 70 mm is resting on HP on the point of periphery of the base. Axis of the cone makes an angle of 60 degree with HP and 30 degree with VP. Draw the projections of the cone when the apex is nearer to vertical plane. So data is given like this. A cone, first of all draw a cone, draw XY line, draw a circle below XY line of diameter 60 mm. See, this symbol is phi, diameter, and draw its axis. Divide the circle into equal number of parts. Name the points A, B, C, D, E, F, G and H, and from these points draw projection line A dash, B dash, C dash, and so on. Height is given as 70 mm. So on this axis, mark a point at a height of 70 mm from this XY line and join these points. Mark point A dash over here, projection from point B dash would be here, projection from point C dash, similarly D dash and E dash would be here. And join endpoints A dash with O dash with B dash, O dash with C dash, D dash and E dash with a full line. So here full line and center line both are there. So we will draw a full line at the end. Now the angle of this cone is given as 60 degree with HP. Angle of this axis. See, in this case, what is angle between this axis and XY line? This angle is 90 degree, right? And this XY line is front view. For front view, this XY line is horizontal plane. So angle between axis of cone and horizontal plane is 60 degree. Here it is 90 degree. So we have to convert this 90 degree into 60 degree. So how to convert that? We need to rotate this triangle in such a way that this angle becomes 60 degree. So at an angle of 60 degree, draw a line. This angle is 60 degree, this angle is 90 degree, so this angle will be 30 degree. So from this point, draw a line at an angle of 30 degree on this side. Project all these points from here by taking radius or by measuring the distance. Anyhow, you have to redraw this triangle and name respective points. From these points, draw vertical lines, and from these points, draw horizontal lines. Find out point of intersection as we discussed earlier and name the points. Join these points with a smooth curve, and that is an elliptical base, and this is apex point O dash. And if you are looking from top, this inner portion will not be visible, so this will be dotted line. And join this curve with this O1 in such a way that it becomes tangent to this ellipse. This line should be tangent. There should not be you should not join O1 with G1 directly. No, they should not be directly joined. They should be joined like this. So this is top view, this is front view. Now second step is given that the angle of axis with VP is 30 degree. This is very typical case. Whenever it is given that the angle of the axis of cone makes an angle of 30 degree with VP or any angle with VP, first of all draw a line at an angle of 30 degree with XY line to the right side of this object. Then mark this point, O point somewhere over here, and draw here true length. True length means this length, this one, this height 70 mm. So O dash to 70 mm, mark here point O or O2, and from this point draw locus of point, that is locus of point O2. So this is point O2, draw horizontal line. What we done? We found we measure this distance, this height 70 mm, and on this line mark 2 points at a distance of 70 mm. One point is O, another point is O2. From O draw a line like this, and from O2 draw locus of point O2. Now mind well, listen clearly. Take O1 as a radius, this one O1, O as a center, draw an arc, and that arc will cut locus of O2 at some point somewhere here. This is point O2, and take this distance over here, then redraw this figure, right? You don't have to rotate this top view directly 30 degree with VP. You have to do correction in angle, and after doing this correction, just follow the steps what we do regularly. Take projections from here, vertical lines and horizontal line from here, find out respective points and join them appropriately. And this is the top view. This is front view of given problem. So I hope it's clear to you. 6 steps are there. It proceeds like this. This is first, second, third, fourth, 5 and 6. Now problem number 2. A regular pentagonal prism of 60 mm long axis, long edges, axis 70 mm long, rests on HP on one of its corner of the base. The slant edge passing through corner makes an angle of 45 degree with HP, and the side opposite to the same corner makes an angle of 30 degree with VP. Draw the projections. For that, first of all, draw XY line that represents intersection of HP and VP, and below XY line draw a pentagon in such a way that this line makes an angle of 90 degree with XY line that is perpendicular to the XY line. Name the points, end points A, B, C, D, E and 1, 2, 3, 4, 5. Take projections on XY line A dash, B dash, C dash, D dash, E dash, and draw a rectangle of given height. Right? Name end points 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. Now angle with HP is given, that is 45 degree. So rotate this rectangle at an angle of 45 degree. We know how to locate the points, how to redraw this rectangle. We discussed earlier, so I am not discussing in details about those aspects. Take projections from respective points, vertical lines from all these points, horizontal line from all these points. Identify the points, join them with a straight line, and this bottom face will not be visible, so that should be joined with the dotted line. This bottom corner will not be visible, so join with the dotted line. Rest all lines are full lines. Now the angle of its axis with VP is 30 degree. Last step. So rotate this top view in such a way that its angle with XY line becomes 30 degree, and redraw this solid such that this angle becomes 90 degree, because this base in HP makes an angle of 30 degree with VP. So here which base is there in HP? This base, that is this. So this makes an angle of 30 degree with HP. Redraw this figure, take projections, find out appropriate location of points and draw its front view. So this is front view, this is top view. Name the respective points and name views front view and top view. This is final answer of this problem. Example number 3. A regular hexagonal prism of 30 mm sides and axis 80 mm long is resting on HP on one of its corner of the base. The axis makes an angle of 30 degree with HP and plan of the axis makes an angle of 45 degree with VP. Draw the projections. In brief, the data can be written like this: hexagonal prism 30 degree to HP and plan of axis 45 degree to VP. That's it. Only this data is enough to draw this problem. So first of all, draw hexagon below XY line of given dimension. Name A, B, C, D, E, F and 1, 2, 3, 4, 5, 6 as the points. Draw projection line from respective points. Mark A dash to F dash on XY line and draw its front view. Right? It's a hexagonal prism, so front view would be like this. Rotate it at given angle 30 degree to HP. Take projections from front view like this. We know how to take these projections. Then 45 degree to VP. So redraw this top view at an angle of 45 degree and take projection. Obviously it's a very simple problem. So this is top view and this is front view of this problem. I hope it's clear to you. Now example number 4. A tetrahedron of 40 mm sides rests on HP on one of its edges such that the face containing that edge is inclined to HP at 30 degree and the same edge is inclined at 45 degree to VP. Draw the projections of solid. Tetrahedron is given. So draw a triangle below XY line. This is top view of the tetrahedron. Tetrahedron means, tetra means 4. Four triangles are joined together and all four triangles are of equal length. That is called as tetrahedron. So this distance is 40 mm. This is top view. Project these points A dash would be here, P dash and C dash would be here. This is apex point O or D. From D, draw a straight vertical line. And this A dash D dash will be true length. So take 40 mm as a radius. From D, draw vertical line. And take 40 mm as a radius. A dash is the center. Draw an arc. So this distance is 40 mm because AD is parallel to XY line. So A dash D dash is true length, that is equal to 40 mm. Now rotate this in such a way that its axis makes an angle of 30 degree with XY line like this. This AD makes an angle of 30 degree with HP, and project the points like this and draw its top view. It's very simple. Now 45 degree to VP. So rotate this figure in such a way that it makes this axis makes an angle of 45 degree with VP. Take projections from respective points and join them appropriately. So this is a tetrahedron of given condition. Hope it's clear to you. And this is final drawing of this problem. Front view and this is top view. Now these two problems that you have to solve in your homework, they are same as the problems that we discussed over here. You can pause here. I am skipping this portion. You read this data and try to solve this problem. Feel free to contact me for any query. Thanks for watching.